Hello everyone and welcome back to a new episode of ILU BIM series. So in the last video you have seen that we have created and exported this model from Autodesk Revit to structural robot structure analysis. Now we are going to add loads on these members and then analyze it and see if we have time we can then design it too. So for assigning loads on these members, let's first select our load types. So for that, just go to the loads and click on load types. So click on load types, you would see we have all these load types. But for this video, we just need the dead and live load. So we'll delete the rest of the loads. So just delete the rest of the loads and just leave dead load and live load here. So delete one by one. So all these are deleted. We just have now dead load and live load. Close this window, and to assign loads, we can click on any of the loads. Like if you want to assign a dead load, click on the dead load, then go to the edit tab, then from edit click on select. This is a quick way to select floors and any other members which you want. You can just select the member type, and then from the properties you can select the property. Like for example, if I click on panel, and it is now based on thickness we have given these are these elements. So if I click on number 4 inch stair slab and I click on this, so you see only the floor stair slab is selected. If I click on this one and select, you see now this one is selected. If I click on both and select this, so all these floors are selected. Another way is just by clicking these and with control, so you can select all these and then apply load. Once these are selected by the selection tool, you can then go to load, then load definition, and the dead load one is selected. So now you have an option, like here now these are all floors, so you should go for surface loads. And for surface loads you have different parameters. We would go for the number one, which is the uniform planar load. Once you click on the planar load, it would ask you for the values, and it is asking the force n kip per feet square. So it is in the z direction and negative z direction. If you see, this is the positive z direction, this is the positive y direction, and this is the positive x direction. But all our load would be gravity loads down in negative z direction, so we would put our load here in negative z value. So where are we getting these values? So as we know, the self weight is already included in this, so here we have to add dead load. So for that, I'll go to the building code of Pakistan, this document, and I'll go to this section where it says dead loads. So in the dead loads 5.6 section, here it says that for partition loads, like in case of floors in office buildings, etc., where partition location are subject to change, where it can change, like the partition walls can change. So it says that uh, a uniformly distributed dead load equal to 1 kilonewton per square meter 21 psf should be added. So you should add this one along with the other dead loads or other loads if your partition walls are going to change. So it can change, like in commercial plaza if they want to increase the number of rooms or number of shops or decrease. So for that, let's just add uh, it was 21 psf, so we can add negative. You can also convert the psf to ksf by dividing it by 1000. So this is 0.21 psf, so you can write 0.21 psf. It is for the change in partition wall, etc. It would be added. And for other dead loads, you can add we can also add that on floor, or we can also add the wall loads directly on the beams if they are acting directly on the beams. So let's add this one for here, 0.21. Click on add and then click on apply. So you see all our dead load is applied here. Let's close this one. This one is selected. Now let's add live load. So select live load from the list here. then go to the load, again load definition, and here select on the surface, then this uniform, and now you see that -0.21 is already present here, right? That was the load which came from dead load. We want the live load, so our live load, let's take it back from the building code of Pakistan. So if you go to table 5.1, it says uniformly in concentrated loads. So this is our office use buildings, and we should take this conservative value of 100 psf, which is, if we divide 100 by, okay, the last one was not actually 0.21 but actually 0.021, and this one would be 0.1. 0.1. So let's do these changes. So let's go back to the dead load, right? So this is our dead load definitions, and here in the surfaces, uniformly surfaces, you see we have this 0.21 here, so we can change this to 0.021 and then click on add, click on apply. If you want to delete the loads, you can also delete the selected load types from here too, deleting uniform load, and then apply, and you see it will delete all the loads from here. Now you can add, and again 0.02 add, and it will be added to here. So dead loads are added here. Let's close this. Now let's select all the floors again, select, go to the panel, then select these both, select all, then go select a live load, then load definition, live load selected, then go to surface, this one, and there select -0.1 and then add, apply. So loads are applied here. Just close this one. So our loads are now assigned to these floors. So I'm ignoring the floor loads, the wall loads on the beams, and these beams are you can also call it framing. And let's just analyze this structure with these loads. So if you go to the dead load one and load definitions, you would see our self weight and mass here. And now before analyzing it, we first need to select a type of code according to which we want to analyze it. So for that you should go to tools, then from tools just go to the preferences, and the preferences is not here. Go to tools and select job preferences, and here you would see design codes. So once you click on the design code, here it is RC structure. So for RC structure, which one you want, it is not loaded here, you can click on more, and here it would load all the design codes. So we want ACI 31814, this one, so you should add this one here, and then click on OK. So see, this is loaded. So our RC structure would be designed according to ACI 31814. Okay, so these are load combination. Should also take this, so take, select the ACI 31814 from here again, select this one. So take the loads combination from this one too. You can OK, score combinations, no when load, these are not present, so you can ignore these. Just click on OK. So now our code is selected. Now we need to analyze it. Okay, so another thing we need to do, we should do the meshing. So go to tools, and in the job preferences, check your meshing properties from here, and click cancel this, and from the analysis go to the meshing, and you can use the meshing by default options. So you click on the default option, it would generate the meshes. So now it is generated the meshes. If you see its 3D view, you can then see its meshes. Turn this off, and now let's select the members and do our start our analysis. So for that, let's go to edit and select. Now first select the beams. So beams would come in member. Yeah, so we have 12 plus 12 and 12 plus 18 members. So we have 12 plus 18 and stair beam, right? We select those, it will be selected like here. We can also turn on the 3D options so we could see our beams. So all our beams are selected now. Let's go to the uh, design tab, and from here required reinforcement of beam columns options, and let's click on the calculation parameters. Once you click on the calculation parameters, you will have these options: standard option and other standard options. So if you want to change its values, you can just double click on it, and its properties would be mentioned here. So if you want to change any properties, its name, then its general information, the unit weight, etc. If you want to change any of the modification factor, or if you're using lightweight concrete, so then you can change this. And if you are going to change the P angle, then the longitudinal reinforcement, you can also add your clear cover here. So for example, we want the clear cover for our beams to be 1.5 inch, right? So you can add that, right? And then which type of bars you want to use, and the characteristic strength of those bars, then the transversal reinforcement, and then the number of legs you want, the stirrups details, all you can select from here. You click on save, it will be saved. Okay, so now it says that it is these options are only for the defaults. If you want to change, you should give it a new name. Give it a new name, click on save. So now it is saved in the new. If you go back to the new, you would see the changes which I made like this. So you go close, and we want to apply it using this. So click on apply, and it would be now assigned to all these. Now turn this off. Now select 12 cross 12. Once this is selected, so these are our columns. Now you go again to the design tab, then required reinforcement of beam columns, again to calculation parameters, and you want to use the same clear cover and other information, you can take that and then apply it, and it would be applied to these columns too. Now another thing which we want to do is the panels. So select these panels. Now all our slabs or floors are selected. Go back to the design tab, and from here required reinforcement of slabs/walls option. So go back to the code parameters, and here you can also go to the table slab and shield reinforcement. Turn this off. Here are options. So which one do you want to select? This is RC shell, wall, or floor. So this is RC floor. You can check its properties from here. Double click on it and see its properties. So reinforcement calculation for shell. So if you want bending plus compression slash tension, or just simple bending or compression tension, whichever you want. So for instance, you want just simple bending, so you should select simple bending only, and then the materials and its properties all you can change from here. So these are all the options which you can then change, and there is these are some bar diameters and etc. Those details, the clear cover, etc. Let's use the default options and click close, and then just apply it. So this is now applied to this one too. Just click this one, close this one, Now these our analysis options are set to all the floors and beams. So we have did all these elements. Now let's go back to the required reinforcement of beam slash columns and just click on calculation. Sorry, not here. Go to the analysis and click on calculations. If you click on calculation, it will start calculation and it says errors have been found during structure verification. Do you want to continue the analysis? Click on yes and then check the error again once the analysis is complete. Click on yes. Now it is more meshing, then consolidation, then reordering, and solution. And now we just have one error and it says overlapping member beams or column not allowed in calculation model. So you see for any reason we have an overlapping beam here, so we should close this one and let's delete this one. So this is now selected. Press delete from your keyboard. The performed operation will cause the changes in the database content extraction data and because not available. Do you want to continue? Just click on yes. And one beam is disconnected from here. Control Z. I think this was some kind of misinformation, so we should go back for the calculation again. So now our calculation is completed. So now our calculation is completed. You should click on the design and then required reinforcement for RC beams columns. Once you click on this, the interface will change a little bit and it would give you the interface where you can see the details of the reinforcement, etc. So for that, now list of the cases. So which cases you want to run? So just click on this one and select both the cases. Close. Then for the second one, select this one too, and then okay, didn't edit these cases, and then for the last one, select this, and then click on calculate. And see it is a calculation for all the members, and how many points you want to calculate the beam. So now it is on 5 points. So for instance, if you want it on just 3 points like the start, mid and end, so you can bring it back to 3 and then just click on calculate. The analysis is completed, but it's still giving me that warning that overlapping member beams columns are not allowed, so it has not considered that in the design. So I'll close this one, and now you see that same error. So let's close this one and see our result here. So you see this is 145 member which has the problem, and the rest of the members, if you see, all the details are here. You see in the 13, so this is the 13 beam here, and here you see the top required reinforcement according to the moment in y direction, and it is 1 at location 1, 6 and 11. So we have divided the beam in 3 points, so it is giving us the reinforcement for 3, and then the top reinforcement, the positive reinforcement, this is giving us the distribution bars, the 2 number 8, 2 number 8, and here's 2 number 8, and then the bottom reinforcement, and this is the bottom reinforcement distribution, and in the transversal reinforcement is giving us 2 number 4 at 5 inch and 5. Here is all the details of the number of bars. So you see it is for the all the beams which we have selected, and for the columns. So this is the information for beams. Look at the beam information, then for the column. So for the columns they have given us the reinforcement. So you look at these, so almost all of the columns have 0.43 inches reinforcement needed. So I'll go for this. Let's look at this one. At this column we don't need much reinforcement, it says 0.26, So we'll look at this and then see why is this giving us such low reinforcement for this one. And let's go down, and for 39, where is 39? Let's rotate. This one is 39, and then this one is 28, which is almost the opposite of the other one. Now if you look at this one giving us more reinforcement demand, and then this one is also very small at this portion. And so these are all the reinforcement distribution which it has given us. One is along one direction and one is along another direction, and it has also given us the number of bars which we should use in our beams and columns. So these are all according to the new parameters which we have considered in this. So this is RC beam and RC column. Let's run the analysis for our slabs too. So just go to required reinforcement RC slab / wall. So click on this. So as like the other one, another window pop up. So I think this was enough for today. So we would check the analysis of the slabs in the next video, and till there you should take care, and I'll see you in the next video. Allah Hafiz.